All right, I'm going to write out the example of when we have a pair of ratios or a pair of fractions that are equivalent, right? So what does it mean? So remember what it means to have a pair of fractions be equivalent. It means that if we've got a pair of fractions that represent the same value, the same quantity um, of a pi, for example, then it means that they are equal fractions, okay? So um, the denominators are different, but the numerators are different also, and these are said to vary proportionally, okay? Now, they vary proportionally because both the numerator and the denominator, in this simple case, increase by a factor of 2, all right? So the second fraction is 2 times larger than the first fraction, okay? And this is known as sort of varying proportion. These fractions are varying proportion. They're proportionally related to one another, and they represent the same quantity because we remember from the pi and the fractions of a pi. If a pi is divided into, let's say, 5 pieces, right? So this is my first fraction, for example, and I have possession of 2 of these pieces. So that's 1, and that's 2. That represents my first fraction, 2/5 of the pi. But if the pi was divided into 10 pieces, so each one is going to get an extra piece, 1, 2, 3, 4, 8, 9, 10. Okay? Then the second fraction is simply divided into more pieces, and I've got 4 of those tenths of that second fraction, right? So we're representing always this quantity here, this chunk of the pi, okay? Whether we use 5/5 or whether we use 4/10, right? It's the same fraction. So these fractions are said to be in proportion to one another. So we have a name for this expression, the expression of two fractions that are equivalent, and that expression is known as a proportion. Okay? And so think of it this way, when things are proportional to one another, if I draw my stick figure, right, my stick figure guy, and let's say the stick figure can be represented by thirds, where the head is always one of those thirds, and then the body is always two of those thirds, right? If I draw a new stick figure um, with the same proportions, it should look pretty similar, right? It's just larger, okay? But it's still the proportions from the head um, to the body are still 1/3 to 2/3, right? But if I were to draw a different stick figure, okay, it's kind of a weird, kind of scary looking thing. And if I were to draw like the unit, this proportion would be way different. See how many equal sort of pieces I've got of this. This is 1, 2, 3, 4, 5, 6, 7. Right. So it is 1 to 6. Right. So 1/7 to 6/7. So the third one, we would say that the third one is actually disproportionate. So it doesn't follow the same proportions when compared to the first and the second stick figure, right? The third one is disproportionate to first and second. So that's what a proportion is. Things that have the same ratio, that are described by equivalent fractions, okay, are said to be in proportion. All right. So that's really what a proportion means. So now let's continue with this. And I'm going to show you how we actually solve unknowns in a proportion. Okay. If we have an unknown in a proportion 2/5 equals to 4, and we don't have the last value. Okay. We're going to represent the value just by a letter, just some letter that's going to be our standing for a number. Okay. There is a rule of proportions that said the cross products, all right, the diagonal products of a proportion should be the same number. The cross products of a proportion are equal, okay? These are multiplications, right? So what we're saying essentially is that the product of 5 times 4 should be equal to the product of 2 times x, all right? And now we already know what x is from our original example. We know that x is 10, okay? So we know that x is 10, and so we can say, we can sort of look up here, right above, 5 times 4, well, that just equals to 20. And 2 times 10, well, that also equals to 20. Okay, so we know that that is true, okay? But what if you didn't know what x was? Well, what we can do is essentially, figure out what x is. What is x? Okay, we know what x is. What if we didn't know? We need to find out what x is, okay? So we got to do something known as solving for x. Okay, we got to figure out what x is, okay? And because x is being multiplied times 2, what we can do is we can apply a little algebra rule that allows us to divide both sides of this expression, this equivalence, okay, also known as an equation, by the factor that is being multiplied to the x, okay? And when we do that, when we divide by it, well, of course, we cancel that out because a number that appears in the numerator and the denominator can be canceled out. And here we can, we can say that 2 goes into 4 2 times, okay? So all we have left on the right side is x, and all we have left on the left side is 5 times 2, and it equals to 10, okay? So this actually gives us a solution for x, and that is precisely the solution for x that we know from our original example, okay? So I want you to sort of go through this, a couple of times, see if it makes sense, and I'm going to sort of give you many more examples of this for you to review, all right? Talk to you soon.